Welcome back at C Squared. In this lesson we will cover what is called composite solids, and we have here some example of composite solid like this one. You notice we have a rectangular prism and a rectangular pyramid. The pyramid is on top of the rectangular prism. Another composite solid here, if you notice, we have a prism. This is the prism. I'm gonna try to show you something like this. This is the prism and half of a cylinder, so it's a composite solid. Another one, here we have two rectangular prisms, and you can approach this one in different way. One way will be this one, you see it. We have this rectangular prism, the one on the bottom, and another one on top of this one. And what about this one? This is a cylinder and half of a sphere. So these are just some example of what we call composite solids. For that reason, let's review a little bit this type of regular basic three-dimensional shape. And this is a rectangular prism, and you notice I put length, width, and height. I think it's easier to use this formula for the volume: length times width times height. For the lateral area, in this case, you're gonna have two lateral faces that are the 2 times W times H, and the front and back, which are going to be length times height. Now for the surface area, you need to add the two bases. So the surface area will be this lateral area, I'm not going to write it again, plus two bases, which are two rectangles, which are 2 times length times width. So these are the formula you need in case you have something like that. Maybe not everything that you see here, but some of the pieces here. Cylinder, the volume is what? Area of the base, which is pi r squared times the height. Lateral area, if you remember that this is what goes around the cylinder, that will be 2 pi rh. Very good formula to remember. And the base of this, in case you need it, will be a circle pi r squared. And this one will help you to find the surface area in case you need it. The surface area is the lateral area plus the two bases. Let's take a look now to the third one, the sphere. Here we have two formulas that are very useful. Remember, this is the radius, like here, the radius, the height. The volume will be 4/3 pi r cube, and the surface area will be 4 pi r squared. And let's see the last two shapes. The pyramid on the left, one will be the volume of that. That will be 1/3 area of the base times the height. The base in this case is that, and you know what, let me write it like this, I think it's better. And the base is going to be, in this case, length times width. You see L and W there. Okay, the lateral area will be the fourth triangle in this case, because this is a rectangular prism. Another formula that you may want to remember: 1/2 the perimeter times the slant height. You know what? But in fact, here let's use the other way. I'm going to say here fourth triangle. And the lateral, the surface area, in fact, will be this lateral area plus the base. I think it's better to use this format. Let's go to the last one, the cone. The volume will be 1/3 area of the base, which is a circle. Here I think we can do that. Pi r squared h. The lateral area is pi r l. What is this L? This you don't see here is this length height, and the surface area will be this lateral area plus the base. And that being said, we can move to our first problem, this one, and we need to find the volume and the surface area of this solid below. And if you remember, this was on the first part. I can break it like this one way. Of course, it's not the only way. And now you can see we have two prisms. We have the one that has 3, 6, and 5. And we can get the volume very fast for the first prism. I'm going to call it V sub 1, length times width times height. That is the formula, if you remember. And in this case, we have 3 times 6. Oops, and by the way, this is not really 5. Okay, the 5 is the whole thing. Okay, this height here, let me move on the other side to make a difference. This height here, obviously, which is the same of this one or any other one like that, back or left, that will be 3. How do we get this 3? Because we have to do this 5, the whole height of this composite shape minus this 2. So 3 times 6 times this 3, just to be sure. And that volume will be 3 times 6, 18 times 3, 54 cubic units. But let's move to the next shape. And that will be this one here, where you're not, I'm going to mark it like this one, that we can see this face. Okay. And this is a rectangular prism. I'm going to call it V sub 2, and will be again length times width times height, but these are different value now. I'm going to use the same formula. I'm going to have different numbers. And now what will be this length here? That will be this 6 minus this 4. That will be 2. What will be this width, for example? That one will be exactly this 3. You notice this 3 is here, so that will be also 3. So 2 times 3 times, and how much is the height of this? A second prism, this guy. That will be this 2, we see it here. So the volume will be 2 times 3, 6 times 2, 12. So now the volume of the composite shape will be V1 plus V2. We add these two volumes, so we have 54 plus 12. And that will be 66. 66 cubic units. 66 cubic units is the volume of this composite shape. Well, let's take a look now to the surface area, how I call it. And in this case, I will suggest you to look what faces you have. Okay, and you can break it based on those two rectangular prisms, or in fact, you can go one by one and see what you get. So I'm going to start with the most complicated one, this one, the front one, right? If you take a look, this looks something like this, which is a composite two-dimensional shape. How do we find it? This is 6, this is 5, this is 4, this is 2, and this is 3. Pretty much what we did before. I can break it like this, and I have a rectangle here, 3 times 6, that is going to be 18. And here we have 2 times this 2, and that will be 4. So this face here, front face, will be that 18 plus a 4, that will be 22. But remember, you have 2 of them. So you're going to see me, I'm going to say back and front. But let's put here back face is going to be the same. They are congruent if you want to use a fancy word in geometry. 22. But then we have more faces, right? We have, let's say, bottom. This one. Let me call this one A1, the bottom. That area will be 3 times 6. That will be 18. It's only one like that. But in fact, if you take a look, this face here, I'm going to call it A2. And this face here are going to be the same like A1. So when in fact I don't really need to find each one, so I'm going to say here A2 plus A3 is 18 also. So we have kind of the bottom, yeah, A1, and the top, which is A2 and A3. Okay, what else we have? We have front and back, we have the left and right. We have the left and right. What about this face here? This one will be 3 times this, 3 times this, for example, this height, which is gonna be 5 minus 2. This is 3 also. Okay, you see I did this 5 minus 2, that is 3. So I'm gonna call that A4. Okay. And that will be 3 times 3, which is 9. We have one more, the one on the right, this one, which is this 3, right? Because it's the same of the other 3 on the left, and the height is 5. I'm call this one A5. A5 or A sub 5 is going to be 3 times 5, and that will be 15. And now the surface area will be the front face and the back face. You can just do 2 times 22 plus the bottom one, which is that A1 18 plus the top, which has the 2 pieces A2 and A3, which are also 18. I could have said 2 times 18. The left and the right. So that's the thing we need to do. We have 44 plus 36 plus 9 plus 15, and that will be 104 square units. Be careful. Let's move to a second example. In this one also we need to find the volume and the surface area, and I'm going to start with the volume. Again, we have 2 shapes there, so I'm going to start and I'm going to call V1, and that will be the rectangular prism. This length times width times height. Length times width times height, and that will be 6 times 6 times 10, and that will be 360 cubic units. What about the prism on top? The pyramid on top, I'm sorry, that will be 1 over 3 area of the base times the height. I'm going to use this formula, and in this case the base is this guy, which is 6, times this guy, which is also 6. 6 times 6, you notice the base is a square, and the height is this 4. So how much is that? So we can simplify here, and we have 3 going 6, 2 times 6, 12, 12 times 4, 48. So the volume of the composite shape solid is going to be 360 plus 48. We add these two volume, no problems here, and that will be 360 plus 48 is 408 cubic units. Let's move to the surface area. Now on the surface area, I really need to be careful for these guys. Okay, and then I'm going to go right here as well. What do we have on the surface area? We have this base. I'm going to call it A1, right? that will be 6 times 6, 36. But then we have these four faces, this one, the one on the right, the one on the back, one on the left. And you notice since this base is a square 6 by 6, okay, that would be not super complicated. Let's find one of them, right? And this is, like I said, 6, and this is 10. Okay, 6 times 10, that will be 60. But we have 4 of those, like I said. So I'm gonna put here 4 times 60. One more time. Why these 4? Because we have 1, 2, 3, 4, front, back, left, right. And now we have one more piece we need to look at. One of these triangles, right? One of these triangles will be, I'm gonna call it A3. And for that reason, probably you want to find the slant height. You see, I'm going to say something like this triangle here. Okay, and in that triangle, this side will be half of this 6, 3, right? Half of this 6 or any other 6, right? This will be 3. The height is 4, so if you remember the Pythagorean triple, this should be 5. So this is the slant height. So now we can find the area of the triangle, which is of that face, which is a triangle 1/2, the base, which is 6 times this slant height of 5, and we get here 15. But how many like those A3 we have? We have 4 of them. So now we have just to do one more step to add all these numbers. So we have 60 plus 240 plus 36, and that will be 336 square units. So you need to be careful of this surface area, because you notice you don't, for example, you don't want to add another base of the prism. It's not there. Okay, so 336 square units. My third example in this lesson will cover this shape, and I said at the beginning we have a prism here. This is the prism. Something like this. Okay, and that will be view 1, remember, length times width times height. So it's going to be 12 times 8 times 10. 12 times 8 times 10. 960 cubic units. Then we have half of a cylinder. So what I'm going to do here, I'm going to find the volume of the cylinder, which is pi r square h. And now let's see what the radius is. If you take a look, this is the diameter, this is 8. So the radius will be half of this. And the height, this height, or the one that I do here, I know it's not perfect, is this 10. So we can go back here and say, hey, the volume of the cylinder now is pi times r squared, it's 4 square, and the height is 10. So we have here 16 times 10, 160 pi. But this, ladies and gentlemen, is the volume of the cylinder. It's not the volume of the half of this cylinder, which is what I'm going to call it V2. So how I get V2? I'm going to divide by 2 this 160 pi, because it's half. And now we can find the volume of this composite shape. Very simple now. We add 960, the volume of the prism, and the half of the cylinder, 80 pi. That's it. You want to evaluate, you have to grab a calculator and do the math for that. Let's take a look to the surface area, how I said. Surface area, what do we have here? And again, you may want to do exactly what I did in the previous problem, right? We have the two faces, front and back, which looks like this. A rectangle and half of the circle. So the rectangle is 8 by 12, which will be 96. The circle, the half of the circle, we're gonna have pi r square divided by 2, right? So, and the radius, if you remember, it's 4, so it's gonna be 16 pi over 2, which will be 8 pi. So I'm gonna say front will be 96 plus 8 pi. The back is the same. The one we don't really see it. So we're gonna have to have these two guys. But now we have this one on the left. I'm gonna try the one you really cannot see it. This one. And that one will be, I'll call it A1, I guess. Let's go like that. And that will be 8 by 10. So 8 times 10. And that will be 80. And then we have bottom and top. This top, you can see it is 10 by 12. Let's say top 10 times 12, 120. But don't forget, we have the bottom, the same thing. And we have one more thing. One more thing is this curve area, which is half of the lateral area of a cylinder. So I'm going to do the lateral area of a cylinder, which is 2 pi r h. And if you want to do it in one step, you divide this by 2. And what do we get here? And we have 2 pi times the radius, which is 4, if you remember, and the height is 10. So this lateral area of the cylinder will be 8 pi, 80 pi. But don't forget, we need to divide by 2. And I'm going to say this is the right side of this composite shape. And this is going to be 80 pi divided by 2, and that will be 40 pi. So now we can go and find the surface area. Okay, what will be that? Front and back. So 2 times this expression, 96 plus 8 pi. Then I said A1, the left side, 80. I said then top and bottom, which are both 122 times 120. And then we have that half of the lateral area of the cylinder, which is 40 pi. I'm going to do just some simplification here, since we can. Distributive property, or you could have added here these two guys, so 96 plus 96. $192 plus 8 pi times 2, 16 pi. Here we have 2 times 122, 40 plus 8320. I think we can do this math, plus 40 pi. And now what we can combine is 192 and 320. And that would be 512. And 16 pi and 40 pi, if we add this, we get 56 pi. This is the surface area. Okay, let's move to Our next example, what do we have here? We have a cylinder and half of a sphere. Very similar approach. We're going to find the volume of the cylinder first. I'm going to call it V1, which is pi r square h, if you remember. Let's see, what do we have here? Pi times, how much is the radius? If you notice, this is not the radius, this is the diameter. So the radius will be half of that. 6 square times the height, which is 10. So we have 36 times 10, 360 pi. This is the volume of the first shape that we can see in this composite shape. Let's go to the second shape, which is half of the sphere. So my first thing will be to find the volume of the sphere. If you remember, that is 4 over 3 pi r cubed. So what do we have here? 4 over 3 pi, and the radius of the sphere is the same of the radius of the cylinder. They overlap, the one face overlap the top. So that will be 6 cubed. So 6 cubed is 216. And we have 4 times 216 divided by 3. Of course, you can simplify, that would be 288 pi. But this is the volume of the sphere. The volume that we really need to find out is the half of the sphere. So I'm going to have this 288 divided by 2, and that will be 144 pi. So the volume of this composite shape will be 360 pi, the cylinder, plus 144 pi. Which is 504 pi. The volume of this composite shape, a cylinder and half of a sphere, is 504 pi. Let's see the surface area. The surface area for this composite solid will be what? Will be the lateral area of the cylinder. The lateral area of the cylinder, which is 2 pi RH. So in this case, 2 pi, remember the radius is the same, 6, and the height is 10. So that will be 120 pi. That's the thing I'm going to put here. This is the first thing I can see it on this surface area of this composite shape. But then we have this base, which is simple, pi r squared, because it's a circle. Pi times the radius is the same, 6, and that will be 36 pi. And what else we have here? We have half of a sphere. So we need to find the surface area of a sphere, and that will be 4 pi r squared, and that will be 4 pi times 6 squared, and that will be 36 times 4. That will be 144 pi. Is this the number we need? No, really. We need half of this. I'm gonna call it here. Let me do like this. Half sphere. That will be 144 pi divided by 2, obviously. That will be 72 pi. This is the guy, the last guy here. Okay, so lateral area of the cylinder, the base of the cylinder, and half of the sphere. So the surface area now will be, we just add those three numbers, 120, 36, and 72. and that will be 228 pi. Another example, we have a cylinder and a cone, very similar with the other one, just we have a cone now, and the other one we have a cylinder and a sphere. So volume will be from two pieces, the cylinder pi r square h, and that will be pi times the radius. The radius is 4 now, right? It's half of this times 6. 4 squared is 16. 16 times 6. That will be 96. 96 pi is the first volume, the volume of the cylinder. The second volume is the volume of the cone, which is 1 over 3 pi r square h. Okay, so we have here 1 over 3 pi. The radius is the same, 4 square. The height, be careful, is this 3. The height of the cylinder was 6. And again, 3 here. So we can really do this simplification here. 4 squared will be 16 pi. Okay, so the volume of the composite shape will be 96 pi plus 16 pi. Which is 112 pi cubic units. What about the surface area? Very, very similar to what we did in the previous problem. What do we have for the surface area of this composite shape? We have the lateral area of the cylinder. 2 pi r h. So that will be 2 pi times the radius, which is 4, and the height, which is 6. So we have 2 times 4, 8, 8 times 6, 48 pi. So that is one piece we need to be aware of in this composite shape. We have the base of this composite shape, the base of the cylinder, in fact, pi r square. So that will be pi times 4 square, and that will be 16 pi. This is the second thing. And do we have one more thing? Yeah, we have the lateral area of the cone, which is pi r l. What is that L? That is the slant height. So let's take a look. This here is 3. This here is gonna be 4. Let me write that a little bit better. This is gonna be 4. So obviously, since this is a right triangle, this is gonna be 5. 3, 4, 5. It's something that you may wanna remember to move fast, the Pythagorean triple. So we have here pi times the radius, which is 4, and the slant height is 5. So that will be 20 pi. So we just have to add these 48, 16, and 20. 84 pi, don't forget that. This is the surface area of this composite solid. And again, you notice, be careful, we don't add a second base pi r square, because that is not really part of this surface area of this solid below. The last question in this lesson, very similar with the others. We have a composite shape, a very nice one, because we have two cones that are the same. And we need to find the volume of the composite shape. I'm going to find the volume of one cone, and then I'm going to double it. the top one, right? Remember, what is the volume? 1 over 3 pi r square h. So let's see if we have all these things. I think we have 1 over 3 pi times the radius. If you notice, this is 6. So the radius will be half of the diameter. If you remember that, we did that today. That will be 3. And the height, now be careful. The height, since these two cones are the same, this is 8, the height will be 4. So let me do that. Height equals 8 over 2, which is 4. So we have to do this multiplication here. 9 times 4 divided by 3, that is 36, divided by 3, 12. 12 pi here is the volume of one cone. But the volume of the composite shape is twice this volume because we have two cones. So we have 2 times 12 pi. And we have 24 pi. And let's move to the last thing in today's lesson, which is the surface area of this composite shape. Okay, and this one is pretty simple, like the volume also. We have the lateral area of one cone twice. So what is the lateral area of a cone? Is pi r L. Remember, the L is the slant height. So let's see. Oh, we have again the shortcut, I think so. This will be 3, I'm sorry, half of the diameter. This will be 4, half of this height. This is a right triangle, so what do we have here? We have again 3, 4, and what will be the next number? If you said 5, that is correct. This length height will be 5. Okay, so we have here pi, radius is 3. And the height, the slant height, to be clear, is 5. So we have a 15 pi for the lather area of the cone. Okay, but remember, we have two of those, top and bottom. 2 times 15 pi. So the surface area here is 30 pi. That's all for this lesson today. I hope you enjoyed these composite solids. It's not an easy topic, but I think you can do it. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.